All right, example 2. And instead of just having random numbers and a scatter plot, here's an applied problem here. So for selected years from 2010 and projected through 2032, the millions of metric tons of carbon dioxide or CO2 emissions from biomass energy combustion in the United States are shown in the graph. Part A, find the equation of the line, which is the best fit of this data with X equal to the number of years after 2010 and Y equal to the millions of metric tons of CO2. We're going to round to 3 decimal places. So I have 2 columns for my years. These are both my X's, which is going to be, I'll do X slash L1, X slash L1. And then 2 columns here for my CO2 emissions, which is my Y, or my L2, my Y slash L2. Now we do need to fix our X's, since X is not just the year, but the year after 2010. That means this one right here, X equals 0, because 2010 minus 2010 is 0. So now we're 2 years after 2010. You can just subtract, and then this is going up by 2, so this is going to be 4, 6, 8, 10. Still going up by 2s, 12, 14, 16, 18, 20, and 22. You do need to make sure, though, that they are doing the same amount of increments. Don't just assume because it starts going by 2s that it's going to continue on. There are times when they start by 2s, and all of a sudden they start going by 3s or 4s or 5s or something else. So do pay attention to how they are increasing. So let's store this into our calculator, and notice I just need the equation of the line that's the best fit. I don't really need a scatter plot here, so I'm not going to graph a scatter plot, but I still need to, if I go back and find that page, I still need to do this portion right here. So I'm going to go to Stat, and I'm already on Edit, so I'm going to hit Enter, and we have our L1 and L2 from last time. So I'm going to arrow up and highlight that list, and I'm going to hit Clear and then Enter, and it wipes everything out. Go over here, highlight L1, hit Clear and Enter, and then enter everything in. So pause the video. I'm going to pause the video myself. I'm going to enter everything in, and then once you have entered this in your calculator, hit play and we'll continue. Okay, hope you had a chance to enter in all of that data. If not, still pause it. And before we go in, please, please, please check. This is when it gets a little bit more annoying because we have bigger numbers and we have a lot more data that we put in, but still check it. Because if you enter in a number wrong, it's going to change this equation and you're going to get it wrong because you entered in the data wrong. Take the 10 seconds it takes to check it so that you don't get it wrong because of that. So I have already checked. Please check. So pause the video if you need to, but here we go. So I've entered in everything. I am still going to go to my Y equals and clear out everything here. I'm going to go ahead and turn my plot one on. And now I'm ready to get my equation. Okay. So now I'm going to go over here to Stat. And I'm following, for the record, these steps right here. So Stat, I went over to Calc. Now I went down to number 4. So either arrow down or just punch in 4. I'm going to skip all of these optional things. I'm going to go down to calculate and hit enter. So here is my linear regression. So we're rounding to 3 decimal places. So my A is about 18.962. That 0 makes that 2 stay. And my B is about 321.509 because that 9 makes that 8 go up. So if I am using this equation of y equals ax plus b, plug in your a and your b here. We've got y equals 18.962x plus 321.509. Okay, so there is my equation of the line, which is the best fit for this data. And as you can see here, that R is still pretty close to 1. 0.997 is very close. It's not as close as our last one was when it was 0.9992, but that's still very, very close. This is still a really good fit of this data. So what does this model predict the millions of metrics of tons of CO2 to be in 2035? So the year, it says X is equal to the year. So this is representing X, but it's the years after 2010. So I need to take whatever year I'm in and subtract 2010, and we're going to get 25. So here, my X equals 25. You can do this one of 2 ways. You can just use this equation, it's not a bad one, and plug in 25. So we would get y equals 18.962 times 25 plus 321.09. And so therefore, y equals, let's see, okay. Oh, that's really small. Okay. There we go. I don't know what I clicked there. Okay, and it doesn't tell me how to round, so I'm just going to write all of those decimals in there. We're going to get 795.559. And it wants us to predict the millions of metrics of tons of CO2. So that's what this is representing right here. Millions of metric tons of CO2. Now, the other way to do this is to put this in your graph and use your trace feature. So if I put my equation here into my y1, my plot 1 has already been turned on, and I am going to hit zoom 9. Anytime I'm using these regressions, I'm going to use that zoom 9 for zoom stat. So zoom stat. Okay, we can see it's a pretty good regression. I want to take away that scatter plot now, and I want to make sure that my window has an X max of at least 25, and it just cut off. So if I don't change that window and I hit trace 25, I get invalid. Why? Because that window was not big enough. So let's change that window to maybe 30. And zoom 9. Oops, I already did zoom 9, didn't I? Let's try trace 25, and we get exactly what we got right here. Part B wants to know the other way, and this is half of the battle. Are they giving me X or are they giving me Y? According to this model, and again, when I don't think I set it up here. When they say model, they're wanting the rounded version right here. According to the model, in what year did the millions of metrics of tons of CO2 emission reach 610? So Y is equal to the millions of metrics of tons of CO2 if they're telling me that that millions of metrics of tons of CO2 has reached this right here. This is my Y. So I am plugging that in for this Y right here. We have 610 equals my equation. Because we're not real familiar with our graphing calculator yet, seems like a lot of times, especially in class, we say just solve it like normal. So we can solve it like normal. We'll subtract this 321.509 over. And so we get 288.491. And then divide. And we get X to be about 15.24. So it says, according to this model, in what year are we in if my X is 15.24? You can round this to 15 and then say that we have 2010 plus 15. So we are in the year of 2025. Okay. Or I'll put this in red. It might be 2026. My math lab is not consistent on this at all. Even though 15.24 rounds closest to 15 years, so we would say we're in 2025. Sometimes it's going to say, okay, we went 15 full years plus a quarter of the way into the 16th year. So we're actually in 2026. If 2025 doesn't work, try 2026. Like I said, it's not consistent on when to round and when to round up. So if one doesn't work, try the other. Now, one of these are our answer. We can also use our calculator instead of using our steps for solving linear equations. Solving linear equations is not hard to do by hand. It's 2 steps. Subtract your constant, divide. But once we get into quadratics and logarithmic and exponential, we're not going to want to do those by hand. We're really going to want to lean in on this calculator bit. So what I would want to do here, if I'm using my calculator, is set one side equal to y1 and set the other side as my y2. Now, typically we always do the left as y1 and the right as y2. But as I said, we've already put this side into my y1. So let's just put this one as my y2 now. Okay, and let's graph. Let's see, we got an intersection right there in the middle, so perfect. So we're going to go to calc, second trace, go down to number 5 or hit 5, hit enter 3 times. And there is my intersection point. So use either of those methods, you get the same answer no matter what.